This is section 6.6, and we are going to start with problem right here where we're going to solve where f of x, and the f of x is actually this curve here that I'm giving you, and where is that greater than or equal to 3. And so if I was shading that, I would shade this part right here. And this is at 1/2 as it shows here, and this is at 8, which it shows here, and it includes it, so it's going to go from 1/2 to 8. And we've done something like this before. And then if I was going to find where f of x was less than, not including 3, it's going to be an open circle here, shaded, open circle here, and shaded. So that's going to be two different regions. If I did this region, it's going to go from -infinity to 1/2, not including it. Or it could be in this region right here, which is not including 8 to infinity. Next one, I want to find where f of x is greater than 0. So it's going to be, this is my 0. It's going to be an open circle, this little hump right here, and open circle and this little arrowed part right there. So this is going to go from -4 to 0, not including. Or it could be in the so this is this section, and this is that section. So that's going to start at 5, not including it, to infinity. And now we're going to talk about horizontal asymptotes. And we have done vertical asymptotes, and we'll talk about that as we go through the horizontal asymptotes. So there are 3 different scenarios that can happen here. The first one is if you have a fraction, you could have a horizontal asymptote. So if the top degree is less than the bottom degree, so I'm going to give you an example of that. If that's the case, the horizontal asymptote is y equals 0, which is the x-axis. If the top degree is equal to the bottom degree, and what does that look like? That looks like this, x squared plus 1 over 3x squared plus 1. So notice that the degrees are the same. And if that's the same, the horizontal asymptote is going to be the coefficient of the highest degree. So it's going to be this coefficient over this coefficient. So the asymptote is a horizontal line crossing the y-axis at -3. If the top degree is greater than the bottom degree, there is no asymptote. So if we had something like x cubed over 3x, there is no horizontal asymptote. I'm trying to move this ahead of screen. So I want to solve this inequality here. So I am going to graph it. So go ahead and graph this inequality. And it looks like this. And I want to know where, if this is my y1, is less than or equal to my y2. And my y2 is going to be right here. So this is my y1, this is my y2, and I'm going to shade wherever my y1 is less than or equal to my y2, which is right there. And if you zoom in, you can see this is just touching here. And so it's going to be from -2 to 2, because it's one region. It's going to go all the way, one solid line there. Because I have a fraction on this one, I might have a horizontal asymptote. So let's take a look at this. I know that the denominator cannot be 0, so my vertical asymptote, is x cannot equal -1. So which is true on the bottom, right? And I'm actually going to change that to x equals -1, is the vertical asymptote, which is a vertical line, right? And my horizontal asymptote I have to decide first, so I know that the top and the bottom exponents are equal, so the degrees are equal, and when they are equal, it is going to be the coefficient of that exponential one. So this here, these are equal. So it's 1 and 1, those are the coefficients. So the horizontal asymptote is going to be y equals 1 over 1, which is 1. And this is the horizontal line. So when you graph this, and you can use your calculator to graph it so you can see what you're doing, I want to know where is y1 greater than or equal to y2. That's what I'm trying to find. That's what I'm trying to shade. So if I was going to graph this right there, so the first thing I'm going to do is put in my asymptote. So I'm going to use red so it matches. So the vertical asymptote is x equals -1, which is right here. And the horizontal asymptote is y equals 1. You're going to see this on your calculator, and you just need to know where it's going, right? So, and then I'm going to graph the line. So I have, this is what my curve looks like. And we know it's not crossing the red line, and we know it's not crossing the green line. Now we know what the red and green line are. And then we have another one down here that has to stay between the red and the green also. And then we have this y2, which is y equals 3. So we have this other curve or horizontal line that goes like this. And we want to know, so just to make sure you understand this, this is my y1, these are my y1s, and this is my y2. So where is y1 greater than or equal to y2? And that is only right here. Kind of what we've already done, just a little bit more complicated, right? So this is going to go from, in this point right here, you can find the intersection of it, and it's -3, 3. And so this shaded area is going to go from -3, including it, all the way up to the asymptote of -1, right? This was x equals -1. And it's not going to include it because you can't touch the asymptote. So this right here is actually the answer to the problem, and then this here is the work of the problem. Next one, solve the inequality. So where is y1 greater than y2? And looking at this y1 again, we have because there's a fraction, we have a vertical asymptote of x equals 0, so it can't cross. So this has to do with the denominator. And then we have a horizontal asymptote, has to do with the numerator and the denominator. And I'm looking at these have the same power to them. So the degree is 1 on both of them. So we're looking at the coefficient of both of those x's, which is -2. So y equals -2 is the horizontal asymptote. And now we're going to graph this. And we've got the vertical asymptote, which is x equals 0. So here's my vertical asymptote. And we got the horizontal asymptote of y equals -2. And then if I look at my calculator, I can see where I'm drawing this. So this first one is going to go right here. The second one's going to go down here, hyperbola. And then my y2 is the horizontal line, y equals 2. So that's going to go right there. And I want to know where is y1 So here's my y1, and here's my y2. Where is y1 greater than y2? And that's going to be right here, that shaded area right there. So I need to find this ordered pair, this point. Make sure that you're able to do that with your calculator. And so my final answer here is going to be this section here. It's going to go all the way to 0 but not include it. And it's going to go all the way to 1 but not include it. So that's interval notation. It's not an ordered pair, just to clarify that. Okay. The revenue from the sale of a product is given by the function R. Use graphical methods to determine how many units should be sold to give a revenue of at least 39,900. So I want to know where R is greater than or equal to 39,900. I want to know where Y1 is greater than or equal to Y2. Oops. Okay, so I'm going to go ahead and graph it. A little bit different than what we've been doing with the asymptotes. There are no asymptotes on here because this is not a fraction. If it was a fraction, we'd have to worry about the denominator not equal to 0. That'd be the vertical asymptote, and the top and bottom comparing the, what am I looking for? My word, degree of the top and bottom. Okay, so if I was going to graph this, I have my y1, put that in green, and that's a curve that looks like this. Makes sense because it's a cube. And then I have my y2, I'll use for blue, that's a horizontal line, and it looks like this. And I want to know where is y1, the green, greater than or equal to the blue. And that's going to be this area right here. So I need to go ahead and find these points. And this point. And then my final answer here, it's only one section here. And this is a word problem. So this is going to be from 10 to 194 units. So it says use graphical methods to determine how many units. So you're going to go from 10 to 194 units. And that is the answer on that one.